Today we're going to be talking about compound inequalities, and I have quite a few definitions to go over. A compound inequality is two inequalities connected by the word and or by the word or. So that's what's important here, the words and the word or. The intersection of a compound inequality is the solution that is common to both inequalities in a compound inequality. And you'll see what we're talking about when you see some examples. The union of a compound inequality contains the solution to either inequality, but not necessarily both. And you'll see what we mean by that in a few minutes. Possible solutions to a compound inequality include two inequalities, one inequality, all real numbers, or no solution. When graphing a solution, be sure to consider whether the solution represents an intersection or a union. And again, you'll see this applied in just a few minutes. With compound inequalities, the solution of a compound inequality can be represented as an intersection or a union and graphed on a number line. And the solution of the compound inequality containing the word and must satisfy both inequalities. So that's a whole lot of information given to you. You'll see what we're talking about that. And what I would recommend is once you see some examples, go back and read that over again from the beginning of the video. So now let's say that we look at this problem here. This is a compound inequality, and we're told to graph x is greater than or equal to -3 and x is less than 2. So here's what we're going to do here. Here's roughly where 0 would be on the number line. Here's 2. Down here is -3. Where we have a greater than or equal sign over the 3, that's a dot that's colored in. X less than 2 is an open dot on the 2. And we want values that are greater than or equal to -3, but are also less than 2. So what we're going to do is just connect those. All right, so this is an intersection of those two answers where values are both greater than or equal to -3 and less than 2. Now let's say that we go to graph this problem here, this compound inequality. Let's graph x is less than -2 or x is greater than or equal to 1. So this involves the word or. We're going to go to where -2 would be on the number line, which is about here. Here's 0 and here's 1. Okay, so x is less than -2 would be represented by an open dot on the -2 with an arrow going to the left. X greater than or equal to 1 would consist of a closed dot on the 1 and an arrow going to the right. So this is what we call a union here. You notice there is no overlap at all. Okay, so here's another example. We have -7 is less than x minus 3. Which is less than 2. And we want to solve this compound inequality for x. And then we want to graph our solution. Well, what we have here, you notice when we solved equations, we had two sides to an equation. In this case, notice we've got three sides to the inequality. If I could draw two lines right down through to create the three sides. I want to get x alone, and the way I would have to do that is instead of having this -3 here, I'd have to add 3. But since there are three sides, I've got to add it to all three sides. So the 3's cancel, and I have -7 plus 3, which gives me -4. In the center I have x, and on the right-hand side I have 5. And I have not multiplied or divided by a negative number, so my arrows still stay the same. So I've got -4 is less than x, which is less than 5. And the way, so basically what I'm saying is that x must fall between -4 and 5 and +5. So here's -4, here's 0, here's +5. We'll put open dots on the -4 and 5. And since it must fall between them, we're going to connect them. So there's another example of an intersection. Let's say we have this example here. We want to solve and graph 4x plus 10 is less than or equal to 26, or -2 times in parentheses x minus 2 is less than -12. Basically what we've got are two inequalities. When they're separated by an or, just solve each one separately and then just graph each one on the line. So let's do the first one. Then we'll do the next one afterwards. So start solving. We'll subtract 10 from each side. So we end up with 4x, the 10's cancel, is less than or equal to 16. Divide each side by 4. The 4's cancel, and I have x is less than or equal to +4. Alright, so there's one answer. Now we need to solve the other inequality. So let's do that over here. We have -2 times x minus 2 is less than -12. So let's do that. We're going to distribute to get rid of the parentheses. So I have -2x plus 4 is less than -12. Now we're going to solve it. So we'll subtract 4 from each side. The 4's will cancel. I have -2x is less than -16. Divide each side by -2. And the -2's on the left cancel, but I've just divided by a negative number, so I have to change the direction of the arrow. So I have -16 divided by -2 is 8. So my two answers are x is less than or equal to 4 or x is greater than 8. So let's go ahead and graph this. Here's your number line. Here is roughly where 4 is. Here's 8. X less than or equal to 4, put a closed dot on the number line, make your arrow go to the left. X greater than 8, open dot on the 8, make the arrow go to the right. So again, here's another example of a union, and the solution, I'll put it right here. So it'll all be together. X is less than or equal to 4, or X is greater than 8. That is it for today. Thank you very much for joining me.